Hey guys, so we're going to have a pretty short video over just finding the arc length and the area of a sector on a circle, alright? And a good essential question here, it's supposed to say EQ, was when do I use radians and when do I use degrees, okay? And so I am kind of predicting the future essential question because you probably have no idea what this essential question means based on just the learning target, okay? But let's dive right in, okay? So we're going to use this paper to help us go through it. Alright, so first off, you'll notice here on this top left box that we have in this top left area, we have two boxes of formulas, okay? And look at where they both have stars. Theta must be in radians, theta must be in degrees. So if you are given a theta in radians, you either use the arc length from this formula or the area of a sector from this formula if your theta is in radians. If your theta means your angle is in degrees, you use one of these two, either this arc length one or this area of a sector one. Okay, so let's dive right into our problem. 49. Find the length of the arc S in the figure. Okay, so here's our circle. Here's our arc. It's right here. We know the radius is 5, and we know the given angle is 140 degrees. Now, the problem here is that the given angle 140 responds to this arc length. Okay, you should remember that from geometry, how it goes to this arc length. This angle 140 subtends this arc. And we need to know the angle that subtends S, the arc length S. That would be this guy right here. Sorry, I'm really bad at tracing. Alright, but that follows this guy right here. Alright, so how could I find the arc length that I need? Well, the angle that I need. The angle that I need, which would be this angle. Well, you know a circle's 360. So you just say 360 minus 140, and that's 220. Alright, so my angle is given to me in degrees, so that means I'm going to want to use one of these two formulas at the top of the page. They're a little hard to see right now on my screen. Okay, I'm going to use one of these two. Now it says find the length of the arc S. So I'm going to want to use this formula right here. Okay, so let's go make that magic happen. Okay, so I can say that S is equal to theta over 360. So what's theta for this problem? 220 degrees. 220 degrees over 360 degrees times 2 pi times 5. And now you'll notice that this says S equals. So then this problem starts off with S isolated. So therefore I can solve for S just by plugging the rest of this stuff in a calculator. So I pull up my handy dandy calculator. 220. Cannot get the 2 to type. 220 divided by 360 times 2 times pi times 5. Press enter and I get 19.2. So the arc length on this arc right here is length 19.2. So S is approximately 19.2. And there we go. Okay, let's go on to problem number 50. Let's try to do problem 50. It says find theta in the figure. Okay, so first off, y'all notice this time that they're looking for us to find theta. Alright, they have given us some information though, so let's look at the given information. We're given a radius 5, and we're given an arc length 10. Okay, so we're given a radius 5 and an arc length of 10. Since we're given an arc length, I want to use one of my two S formulas. Now, the difference between the two S formulas is that one is in radians, one is degrees. What do they ask you to find in this problem? Theta. They ask you to find an angle. Well, they don't tell you if they want it in radians or degrees, so it's up to you. You get to decide, would you rather be in radians or would you rather be in degrees? Personally, I'm going to use radians because the arc length formula for radians is S equals theta R. That just looks like a whole lot easier than the other one. So they told us that the arc length is 10. So 10 equals, and I don't know theta, times R, which is 5. So then to solve for theta, I should divide both sides by 2. So I can say 2 radians is equal to theta. And there we go. Okay, let's try to do 51 now. Okay, 51 says find the radius of the circle find the radius R of the circle in the figure. And it tells me that this is length R, the arc length is 8, So then I can say that S, which is the arc length, is equal to theta R. Now why did I write S theta R? Well, I did S because I knew an arc length was 8. And then I did theta R, I used the radian one because it gives me the angle, the theta, in radians, 2 rad. That means radians. So I know I want to use this formula instead of the other S. Okay? So I know the arc length, it's 8. So I can say 8 is equal to 2, that's my angle, times R. I don't know what R is. So then I need to divide both sides by 2 to get R by itself. And I get that the radius is length 4. Okay, let's do one more together here. Well, let's do one more on arc length together here. All right, let's do one of these word problems here. I mean, I say word problem. It's not really a word problem. One of the ones that does not have a circle drawn out for us right away. Let's do one of the little more complicated ones. Let's do problem 56. Okay, a circular arc of length 3 feet subtends a central angle 25. Find the radius of the circle. Okay, so first off, if you want to draw this out, it is a arc of length that has a central angle of 25. So, let me jump back into my whiteboard kind of thing here. I clicked the wrong button. Oh, bother. Oh, bother. So, let's go ahead and draw our circle here. Alright. So, there's that. And then it told me that it was going to be with an angle of 25. Okay, apparently that curves. That's not what I wanted. Let's try this one. Told me it was going to be 25, something like that. Okay. Okay, I don't know how to delete that. Okay, we're just going to delete that. Okay, this is a waste of your time and my time. My apologies. Okay, let's just pretend that looks better. Okay, so pretend that's more central. Alright. So my inside angle was 25, and then it told me, I believe, that my arc length was circular arc of length 3. So this is length 3. Okay, so, and it says find R. So first off, guys, look at the given information. You're given an arc length, so you know that this is going to be some kind of S equals. Then look at your angle. Your angle is in degrees. So you know you need to look at the formula that says theta must be in degrees, which is S equals theta over 360 2 pi R. And what it wants me to do, it wants me to solve for R. They gave me an arc length, so I say 3 equals 25, because that's what the theta is, over 360 times 2 pi R. Okay, so here's my suggestion to you. Multiply these 3 things together. Okay, so in other words, pull out your... Okay, that's fine. What am I doing here? Why is this getting weird? Okay. So, pull out your handy dandy calculator. Type in 25 over 360. Okay, and then do multiply by 2 second pi. Alright, so that's going to give me a number. Alright, 0.436. So I can change all these 3 numbers just to being 0.436 and then still times R. 3 equals this. Now, what would I need to do to finish off for R? Divide both sides by 0.436. 6. So then you grab yourself your handy dandy calculator again, and you just say 3 divided by 0.436. And so we get 6.9. And there we go. So the radius is approximately 6.9. Awesome. Okay, so let's dive into doing some other problems now. We've done several arc length. Let's do area of a sector. Okay? Find the area of the sector shown in each figure. Alright, in this first one, they give me the 80 degrees inside. They give me the radius 8, and it says very clearly, find the area of a sector. So since it's asking for me to find area of a sector, I know this is an A equals situation. Then, look at your angle. What is it given to you? As degrees, then you're going to use this formula right here. We know that theta is 80, so we're going to say 80 degrees over 360 times pi, and then they tell me what R is, it's 8. So times pi 8 squared. And since you already have the area variable A isolated, you can just plug all this good jazz into a calculator. So you can say 80 divided by 360 times pi times 64. Press enter, and I get 44.7. So then my area is approximately 44.7. Alright, I suggest you stop and you try to do part B on your own. Okay, so hopefully you're just unpausing your video and you've tried B on your own. And you're kind of like, oh, okay, the angle they gave me was radians. They want me to find area, so I know I need to use the top box A formula. So A is equal to, and it was theta, 1/2 theta, pi r squared. If I'm not mistaken. I do need to pause real fast and double check. Sometimes I will forget a formula. No, 1/2 theta r squared. Perfect. Oh, okay. No pi. No pi. No pi. Okay, so I added something I didn't need. I'm glad I double checked myself. 1/2 theta r squared. And they told me that theta is 0.5 radians. They told me that the radius was 10. So I just plug in 1/2 times 0.5 times 10 squared. And you jab all that into a calculator and you're going to get 25. Wonderful. Alright, let's try 60 now. Let's try doing 60 together. Find the radius of each circle of the area sector is, 12. So first off, find the radius of each circle if the area of the sector is 12. They tell me what A is. A equals 12 for both A and B. A equals 12. They want me to find the radius, so I'm searching for R. But the fact that I know it's A equals 12, I know I need to use an A equals formula. Now look at your angle. It's given to you in radians. So for part A, you need to use this one. A equals 1/2 theta r. You know what A is. They gave it to you. It's 12. Is equal to 1/2 times theta. They told you what theta is. It's 0.7 times r. And we want to solve for r. So again, just like I did earlier, I'm going to multiply 1/2 and 0.7 together. And that's going to give me 0.35. And that's so then I just need to divide both sides. It shouldn't be r squared. It should be r squared. It should be r squared. And then I'm going to divide both sides by 0.35. Alright, so I divide 12 divided by 0.35. 12 divided by 0.35, press enter, and I get 34. And then what am I going to need to do that number? Square root it. That's right, to get r by itself, I'm going to need to square root it. And I get 5.9. So r is approximately 5.9. Okay, I suggest you stop and try B on your own. Hopefully you're just unpausing and now you're like, okay, B is easy because it gives it 2 degrees. I still know that the area is 12. So instead of using the other formula, I'm going to use A is equal to theta over 360, and this one is pi r squared. Okay. So then I know theta is 150, so I'm going to say 150 over 360 pi r squared, and then I know that area was actually 12, so I can say 12 equals these things. Well, just like I did in the earlier problem, guys, first thing I'm going to do is I'm going to multiply these things together. So I'm going to pull up my handy dandy calculator here, and I'm going to type in 150 divided by 360. I'm going to multiply that by pi, so second pi, press enter. So this is 12 equals 1.3 times r squared. So I'm going to have to divide 12 by 1.3, press enter, and then I'm going to square root this so that I can get r by itself. And I get 3.03. So the radius for part B is simply 3.03. Okay guys, I tried to speed it up there at the end. I hope this video made sense. Please let me know what questions you have. Please don't stay confused. Alright, send me a reminder, send me an email, stop by for tutoring, even though I do know I disappear a lot from meetings. So, try to talk to me in advance. Alright guys, have a wonderful weekend.